Hi everyone and good days. So today our topic is about the introduction to mathematical economy. Before we moving on topic for today, I will introduce myself. My name is Jia Jie, Nomometric 2S7649 is from course Introduction to Mathematical Economy, Group C. Now I am a student, Bachelor of Science Economy in UUM. Currently semester is the first, then my academic qualification is STPM. Hey guys, so I will share with you all three things that I want to focus in this video today. First is capacity, second marginal cost and interpretation, third revenue cost and profit function. So I hope you all can enjoy it. Let's go. We start it for now. So let us have a look on the question A. Determine where the function fs is conveyed upward and where it is a conveyed downward. Conveyed upward is a up, then conveyed downward is going to down. So it is simplified to positive and negative. First, determine the values of x for which f is 0 or where f is not defined and identify the open intervals determined by this number. Determine the sign of second derivation of f in each interval found in step 1. To do this, compute second derivation of fc where c is any confidently choose a test number in the interval. If second derivative of fc is more than 0, f is conveyed outward on that interval. If second derivative of fc is under 0, f is concave downward on that interval. Go back to the question. The first step we need to do and solve this question is use the differentiation using the power rule. So we can see in the slide they have the power rules of differentiation. Then we use it to answer it. First derivative we will get the 3x squared minus 12x with 18. Then the second derivative we will get the 6x minus 12. Next, the second step is let the second derivative of s equal to 0 to find the interval. And then we will get the answer s equal to 2. Therefore, the interval is negative infinity to 2 and 2 to positive infinity. So we go to the step 3 to identify where concave upward or downward by testing the number in the. Make it more organized and easy to see. You can first list down the interval column, then second column you can insert the number, then you wish to test. Then, the criteria is must be the interval. So in this case, I choose negative 1 and 3 to test the value of second derivative of f. Following the third column can write down the number you obtain by inserting the test number into the function. Following step is to determine whether it's concave up and downward. As a recall back, if the value of second derivative of fc is greater than 0 on the interval and it is upward and vice versa. In secondary function of fx is more than 0 for each value of s on the interval 2 to infinity positive, then f is concave upward on interval 2 to positive infinity. Since secondary function of fx is less from 0 for each value of x on the interval is from negative infinity to 2, then f is concave downward on interval negative infinity to 2. Now we move to next question. Question B, which is related to the marginal cost and how to interpret it. We see the question first. Suppose that the cost function for a manufacturer is given by function cx. Describe the behavior of marginal cost function. Question in question B, we need to find the marginal cost function. Second is describe the behavior of marginal cost function, whether concave upward or concave downward. Prove your answer. So let's go. We answer these two questions in question B. Guys, so find the marginal cost, we need to find the derivative of cost function using the power rules. As similar to the previous question also, so we will get the marginal cost function here. Next, in the second question, in question B, we need to redefine its concave upward or downward. We need to find the second derivative of cost function and the interval. As similar to the previous question in question A, so this is the secondary function of the cost function. And now let it equal to 0 to find the interval. So the answer we get there is 1000. Interval is negative infinity until 1000 and 1000 to positive infinity. Going on the next step, we need to test the number to check with interval concave upward or which downward. Follow step as previously mentioned, so the first column will be in the interval, then test number, which are 500 or 2000 in this case. Just to remind, the test number can be any number within the interval. Then we find the value of second derivative of f, where we got negative over 1000 and 3 over 500 in this case. Let's write down the sign and also whether it's greater than 0 or less from the 0. We can determine concave upward or downward. Since second derivation of fx is more than 0 for each value of s in 1000 to positive infinity, then f is concave upward on interval 1000 to positive infinity. Since second derivation of fx is less from 0 for each value of s in negative infinity to 1000, then f is concave downward on interval. So now we move to last question in this video. Question C, revenue, cost, and profit function. So let us read the question first. A company has established that the revenue function in linkage ratio is function of Rx and the cost function in linkage ratio is Cx. Okay, so we can see here, the first question is we need to find the level of production that will a maximum profit for the company. Then second is we need to find the price per unit to maximize the profit. Okay, so for first step, we need to find the production level that maximize profit. Find the profit function. We use the total revenue minus the total cost, and here is what we will get the answer. After we get the profit function, we can find out the first derivative of profit function. Then using the power rules previously mentioned, we will find the Px and let it equal to 0 to determine the level of production will maximize the profit. When Px equal to 0, we will get the two level of production, which is 2 and 12. Therefore, to find the exact unit that maximize profit, find the second derivation of Px. So we will get the answer is negative 6x at 42. Step 5, to know if this is a maximum or minimum or an inflation, check using the second offer condition, SOC. Okay, so when we follow the step 5, we will get the answer of second derivation of Px is equal to negative 6x at 42. When x equal to 2, second derivation P2 will get the 30 and more than 0. When x is equal to 12, second derivation of Px will get the negative 30 and less from the 0. Level of production equal to 2, the number of 10 is positive 30, which is greater than 0, and therefore it is the minimum level. Well, when the number of production is equal to 12, the profit function is negative 30, which is less than 0, and there is a maximum point. So since second derivation of Px is less from 0 when the x equal to 12, which is the maximum point, therefore the level that will give a maximum profit of a company is 12. Last question is price per unit that maximize profit. So we use back the level of production that is 12, insert it to the profit function. Then we will get the price per unit to maximize profit is 102.67 cents. Thank you very much, guys. So I hope you all can learning something from my video today. So hope you have a nice day. See you next time.